It's space time. Welcome back. This is Neil. We're here on episode 2 of our career in the Galileo Planet Pack of Kerbal Space Program. Last time we had 2 unsuccessful satellite launches where we failed to reach orbit, although we did complete 3 of the 4 missions that we had. This time, I've gone ahead off camera and redesigned our launch vehicle to use liquid stages, and we're going to hope that it gets to orbit this time. So without further ado, we will 3, 2, 1, ignition, liftoff. We already, did we? We actually did not get the science. Oh, we did. We got the science from the surface, so we can go ahead and take the flying at Gale science. And we'll start turning over. We have much better control with this liquid stage with vectoring. Hopefully it should get the job done. Like before, our goal is going to be to try to get into a synchronous orbit, but the primary goal is to get into any orbit. We will need this, we'll need to have a few of these in order to actually expand our space program and be able to control all of our probes. Uh-oh. We're losing control again. No, 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 no! Yes, up is good. Up is good. We're just going to let him stay at this angle. It's not efficient, but it should at least provide us what we need to get high enough to use these upper stages to get into orbit. Got an apoapse almost at 40. We've reached 40. Alright, we can turn a little bit more. Ideally, we want to be turning much more quickly, but we're having a hard time controlling our spacecraft, so I don't know why that is exactly. We're going to have to figure it out, but we have an apoapse out of the atmosphere, 88, 89, 90. Okay, that's good. We're not going very fast, though, so that is a problem, but it's something that we will be able to solve. We should be able to shortly extend our antennas. Can we not? I guess we can't yet. We can. I don't know why the action group isn't working, but we do have our antennas extended. We'll go ahead and transmit the data that we have. Great. We'll ditch this stage now that we're up out of the atmosphere. And we're just going to burn I'm going to let this get up to maybe 100. And then we'll burn as we get closer to the apoapse. I'm going to turn the spacecraft down so that as we lose control, I'm thinking we still will have control as we get to the apoapse, but just in case, that it will be pointed the right direction at the right time. Alright, full throttle. We might actually succeed this time. Let's give ourselves a little rotation here. We're actually just going to let this stage burn out, and then the next stage is going to adjust our orbit. Just to be sure, let's watch what... So we have passed the apoapsis. I'm going to go ahead and burn up a little bit so that that doesn't, so that we don't fall back down. While we're up here and we have signal, let's go ahead and transmit the data from space. Uh-oh. That's not ideal. No power. All right, we are in orbit. We'll go ahead and ditch that stage. The apoapse is on the other side of the planet. We're not going to have control over there. So I'm going to point retrograde, which is going to put us prograde when we get over there. Good news is we have completed orbit Gale, escape the atmosphere, scientific data, launch first vessel. So we've completed all of the contracts that we've taken. We're at a 7.6 degree inclination. We will fix that, but only when we get up to the orbital altitude that we actually want. Because the higher you are, cheaper it is. Go ahead and do some physics work here. While that goes up, ideally we want to get the apoapse up to about 2868, plus or minus, which is the altitude that we'll need for a synchronous orbit. All right, 22, 23, 24, 25, 26, 27, 28. 2885, not too bad. All right, so the next step, we'll warp until we have some control. We should have control near the apoapse, actually, I hope. So if we don't, that's going to be a problem. Let's see. All right, so we have it near the periapse. So what we're going to do is turn retrograde so that we're facing prograde when we get to the apoapses. The good news is, if we set up a synchronous orbit here, we do have line of sight to the Space Center, and we will be able to communicate with it. Do we have the fuel? We should have enough fuel. So what we're really watching for is this orbital period. We want that to get up to 6 hours. It's actually going to say 1 day. 6 hours is a Gale or Kerbal day. It's basically the same. Basically, it is the same. Although a lot of other things in the system are different. Since we have control, I can point more closely to the prograde, which is great. All right, we're about 5 hours. I'm going to actually let us get closer to the apoapse again, because I want it to be close to circular. It's not going to be exact. It's not going to be stationary. It is going to be a synchronous orbit, which will be good enough for our purposes. And since we have control, that's great. We can go ahead. One minute. Okay, so we're actually a little bit beyond what we want. 1 day and 1 minute. right, we're off by less than a second. That is good enough for us. Now we also have, oh, that's pretty. So since we have line of sight, we can transmit the scientific data that we've already collected, which is in space near Gale. Great, and we can go ahead and collect scientific data. We're going to keep it for now because we don't have enough power to transmit it. Well, there we go. GaleCom 1 is in its orbit. How much fuel do we have? We should have enough to fix the inclination too, just for kicks. So our surface speed is 130, and that's probably because of the inclination. But we should almost always be in line of sight of the Space Center with this spacecraft, and that is what we need. Alright, now that we're back here, we can go to mission control. We'll take the mission to explore Gale, which is return to Gale from orbit. We can also put a satellite in a specific orbit. Wow, it's a really high orbit. That's a good amount of money, so we're going to take it. And orbital station around Iota, that's something that we're going to want. Even if we're not going to do it yet, we have 14 years basically to complete it. So we're going to take it because I don't know if it's going to disappear. And anything else that we're interested in here? No, we're good. Okay, great. We have 788,735 Kerbucks. That means we've actually made a good amount of money. And so, what missions did we say we have? So we can actually try to accomplish both this mission and the Explore Gale mission together. And the way we're going to do that I'm going to do a few things here. We're going to add this. We're going to switch to the swivel. Go back, bring back up the Delta V stacks. Very nice. Now, because we're not going to leave this in orbit, we'll get rid of that. Instead, we're just going to put this guy on the side. And how are we parts? So that's going to be our problem here, possibly. Is parts. The thermal. We're going to put the small heat shield. Oops. Okay, and I hope that's going to allow us to recover this vessel. And the other thing we're going to do, because we might have to time the orbit for the right inclination, we're going to put one of these. And we don't actually need it for this rocket, except for the fact that it keeps power flowing to it if I have to time warp while it's on the pad. And that's going to be very important, possibly. So this is our orbit. It's pretty much equatorial. So we're just going to launch a standard launch and then fix the inclination as we get there. I hope we have enough delta V. We're going to be cutting it a little close. It's a really high orbit. It's going to take a lot of delta V to get to it, but let's find out. 5, 4, 3, 2, 1, liftoff. I'm going to start the turn a little bit later for two reasons. One, since we have to go up so high, it shouldn't be nearly as much of a problem, but more importantly, I do want to keep control this time for a change. We've been having serious problems with that the past pretty much every launch. Alright, what we can do is open the orbit info, and we'll start. See? We turn a little bit, and we lose control. Uh-oh. Up, up, up. Keep going up. That's what's important right now. No! So as we've said, we've had problems. I really should have put fins on this guy. But if we can get up out of the atmosphere or pretty close on this stage, we hopefully can still complete the mission with those two upper stages. As we saw, they have a lot of delta V in them, so I really need to figure out what's causing these to lose so much control. Okay, so we are going to get up out of the atmosphere on this stage. And we're going to go ahead and keep burning. We're basically going to let this stage burn until it runs out. Can we? Oh great, we've got signs from the upper atmosphere. Oh right, we don't have any antennas to deploy. I forgot that we used that design this time. Alright, so a somewhat long burn, but we're just going to let it burn out because the apoapse needs to be so high anyway. Might as well let him burn until this engine burns out, and then we'll figure out where to go from there. We may need to go back and upgrade the tracking station in order to properly accomplish these missions. But we can at least get him somewhat close, definitely get him in a stable orbit, and from there, figure out what to do. I'm going to point him basically here, so that hopefully he'll point prograde when we get to the point. And very conveniently, we have a connection via our relay set, and that is what it's for. At the same time, how far are we from the... Great, so let's actually burn north at the same time. Alright, we'll get back to mostly prograde. We are going to need to save fuel to deorbit. What's our inclination here? Looks like 9 degrees. Wow. At this point, we do want to see our delta V info. Basically want to keep us about 100 delta V to deorbit at least. Probably more. I didn't even see. Oh, great. So we only needed a thermometer, which we have. Speaking of which, we should be able to transmit some data. What? Why are they not in range? Oh, is it because it's not direct? Okay, so basically, we do have a problem that we're not going to be able to reach the designated orbit. So we're going to go ahead and deorbit him and at least complete one of the missions. It's not an ideal trajectory, but we should be able to get a periaps in the atmosphere. Now the big question is going to be whether we're aerodynamically stable and we actually are able to keep the heat shield in the direction of the airflow to protect us. 34 should be good. Here we're in the atmosphere and we are facing the exact opposite direction of what we want to be. Let's get rid of the SAS and hope that it turns himself. Okay. Not ideal. Oh no. Look at those heat. Look at that heat. Come on, turn, turn, turn. Good. As it rotates, the heat goes down. And it's trying to put itself retrograde, but is it going to be enough? If those are just the solar panels, we'll be okay. If it's a probe core, we're in trouble. Come on. Get through the heat, survive the heat. It's borderline. Okay, so we've definitely re-entered. We're getting closer and closer to holding retrograde. How much ablator have we gone through? No. It's actually burning through the ablator relatively quickly. And we have survived. Oh no, but we didn't put a parachute on it. Okay, well, that's a problem. Not much we can do about it now. Just watch him crash. What an idiot. You know, for someone who's pretty good at this game, I've been messing up a lot in this career. All right, well, we'll leave to the Space Center. That was definitely not successful. We'll have to try again next time. We're going to try to complete both of those missions in one go again. In order to do that, we can go ahead and collect that debris. Oops, wrong button. Didn't mean to go to the tracking station. What I meant to do was upgrade the tracking station so that we'll be able to use that in our next mission. And how much is it? 225 and 50. Okay, great. We're going to upgrade both of these as well, which is going to be very helpful. So next time we're going to try to complete those two missions again. Thanks for watching. See you then.